So in our final video for section 2.3, we'll be discussing the last objective I had out of the two that were given initially. In this video, we're going to talk about how we might find all of the zeros of a polynomial using polynomial division. Now, in order to do this, we first have to write down a couple of rules. So here's the first one. We're going to say that x equals a. So in this case, we're saying a is just some number. A is a number. A is, I'll say any number so I don't have too many a's in there. Oops. A is any number. So x equals a is a 0. Lots of typos right now. Of a polynomial p of x if x minus a is a factor. Now this may seem like a relatively simple result. We've already talked about this. If x minus 2 is a factor, then x equals 2 is a 0 or a root, etc. So that's all we're saying here, but it's worth reminding everyone. So we kind of use these words interchangeably. Okay, now another fact we're going to use today is that if x minus a is a factor of a polynomial p of x, then when dividing p of x by x minus a, we should end up with a remainder of 0. So this is just saying that the remainder should be 0 when we divide them. And that tells me the final piece of information I want to give you here. Then we can rewrite p of x as q of x, whatever the quotient is, times x minus a. Now all of this, hopefully once we see some examples, will seem somewhat obvious. We have often rewritten polynomials in their factored form, but these facts do kind of get lost when we're dealing with division because there's so much else going on that we forget about these sorts of details. So let's go ahead and take a look at an example problem. The first example I want to do is, let's just go ahead and show that x plus 1 is a factor of the polynomial p of x equals 3x to the 4th plus 7x cubed minus 13x squared minus 23x and then minus 6. Now hopefully you've had a chance to write down synthetic division because I will be using synthetic division exclusively when I can. So in this case I'm going to go ahead and divide p of x by x plus 1, and I'm going to use synthetic division to do this. So I'm writing down the coefficients. We'll bring down the 3, multiply by negative 1. So in this case, my remainder is 0. So that tells me that x plus 1 is in fact a factor. Now, I didn't ask you this in the problem, but this tells me that p of x equals x plus 1 times, now I'm using the alternate version of how I expect you to write your answers. This was in a couple of videos ago. But it's going to be multiplied by the polynomial I got when I divided. And I'm definitely going to run out of room here, so let me go ahead and open up that parentheses again. So I'm at a point now, let's say this was a problem where you're trying to find all the zeros of p of x. You have now one of them in that x plus 1, but we are missing one for the 3x cubed plus 4x squared minus 17x minus 6. So I'm going to give you a little bit more information. I'm going to also tell you that x minus 2 is a factor of p of x. Now notice in this part here, this equation that I wrote here, x minus 2 can't divide the x plus 1. That's something you can just get by looking at it. You can't take x plus 1 and divide it by x minus 2. That wouldn't work. You'd end up with a remainder. So that tells me that x minus 2 must divide the other part of this, the 3x cubed plus 4x squared minus 17x minus 6. So I'm going to go one step further with this polynomial, and I'm going to go ahead and do this division now. So I'm going to take 2, the 0 of x minus 2. I'm going to write down the coefficients. Whoops. I wrote down the x as well. I meant to only write down the coefficients. And let's go ahead and do division here. So 3 comes down, that's 6, 10, 20, 3, 6, 0. So now I'm left with, well, first of all, it's good that the remainder is 0. That means it is a factor. But now I'm left with 3x squared plus 10x plus 3. So what I could say now is that I know p of x is, I already had x plus 1, but now I know that I have x minus 2. And then I'm left with 3x squared plus 10x plus 3. So let's just say for a moment, let's go back to the initial problem. Because I didn't really give you all the information to start this problem off, I just kind of went with it. But let's just say I had said, you're given this polynomial p of x, and I need you to find all the zeros. And then I told you x plus 1 is a factor, so you did that division. I also told you that x minus 2 is a factor, so you did this division. Now you're at a spot where you can actually find all the zeros. So let's take a look here. X plus 1 equals 0 tells me that one of those zeros is negative 1. X minus 2 equals 0 tells me that another one of those zeros is x equals 2. And then I have to solve 3x squared plus 10x plus 3 equals 0. You can always solve a quadratic. Whether you have to use the quadratic formula or factor, you can always solve this. So I'm going to go ahead and factor. 3 times 3 is 9. Something that adds up to 10 and multiplies to 9 would be 9 and 1. So I'm going to go ahead and write down these factors here. So 3x. Keep in mind, I did this relatively quickly because I already knew what the answer would be. If you were to do this process by yourself, there would be a lot of steps in between involving some factoring by grouping. But here's my final answer, and so then I get my last zeros, which look like this. And they all have multiplicity 1 because they only show up once in their factored form. Okay, so that problem was a little bit discombobulated because I didn't give you all the information at once. I sort of slowly built to it. I want to kind of wrap that problem up, and then I want to do one more full-length problem that would look more like what you might see. So just as kind of a review of that problem, a summary, we did synthetic division. Twice. And then once we did that, we had all the factors we needed. Sometimes you only have to do it once. If it's a cubic, you'll only have to do the process once, and you'll be left with something you can solve. So then we set each, so I'm going to put that here, or once, if cubic, if your initial polynomial is cubic, set each factor to 0 and solve for x. And so that's really the process. You do your synthetic division, and then whatever you're left with, you can set all of that equal to 0, and that'll give you the rest of the factors. So like I said earlier, let's go ahead and do one more full-length problem. Let's say that we want to find all x-intercepts and their multiplicities of the function p of x equals 4x to the fourth plus 3x cubed minus 33x squared minus 40x plus 12. And I'm going to give you some information as well, given that -2 and 3 are zeros of the polynomial of p of x. All right, so something to note is that if -2 is a 0, that means x plus 2 is the factor, and x minus 3 is the factor over here. So let's go ahead and do synthetic division. I'm going to start with -2, 4, 3, -33, -40, and 12. We get 0, so that's good. Next, I'm going to just kind of make a note here that this is the polynomial 4x cubed minus 5x squared minus 23x plus 6. I don't have to, but that's what I'm left with. And now what I can do is I have to divide by x minus 3 at this point. So let's go ahead and take 3. We're going to divide our new polynomial by x minus 3. Uh-oh. I messed something up. I noticed that I wasn't going to get 0. Still not going to get 0. Oh, I see what I did. Pardon me, I was using the original polynomial for some reason. Okay, 4, -5, -23, and 6. There we go. Thank you for your patience while I erase this. There we go. So still bring the 4 down, 12, 7. This should actually now be 21, which means this will be -2, -6. There you go. Okay, it actually got 0. Good. All right, so let's just kind of take a deliberate pause here, and we're going to write down what we know. We know that p of x is x plus 2, x minus 3, and then this part we have to convert into a polynomial. In this case, it's a quadratic. So we end up with this is our polynomial. So this right here, this polynomial p of x, is equivalent to what I've written down here. Based on that format I told you could write your answers in a couple videos ago. All right, let's go ahead and solve. We have x plus 2 equals 0. Well, we already know that this was -2. We already did this process, or this was already given to us. The last step is going to be to figure out what this is. Let's go ahead and figure out two numbers that multiply to -8 and then add up to 7. It'll be 8 and -1. So to kind of fill in those details from before so you get a better feel for how this works, I'm going to rewrite it. factor by grouping. And so then I end up with this in factored form. And so my final answers are these and these. Now you'll notice that there is a repeated root. X equals -2 repeats twice. So we would actually say that the zeros are x equals -2. Its multiplicity is 2 because it shows up twice. X equals 3 has a multiplicity of 1, and then x equals 1/4 has also a multiplicity of 1. And so this would be the final answer after quite a few steps, but with synthetic division it goes pretty quickly overall. And that concludes our discussion on synthetic division. Once again, we started off with just sort of division. We built up to synthetic division, but also you should be familiar with regular long division. And then we concluded with finding all the zeros of a polynomial.